Moving west, Raminda, in behalf of Honn Kao, induced seismicity related to shale gas and oil development. You're on, Ramin.
Hello. So I'm here on behalf of Honn Kao, who is not available. So I'm going to talk about the key achievements of induced seismicity research projects from 2014 to 2019. Next slide, please. Okay, I'm not going to read the entire abstract, but I will talk about the key achievements in this field of study, and briefly introduce some of the key components of it. Next slide, please. First of all, we would like to appreciate our key project members, including research scientists, research associates, postdoc fellows, graduate students, and seismic analysts from different offices and research centers. Next slide. And also we received supports from a numerous number of territorial, provincial, and provincial collaborators, research institutes, and universities. Next slide, please. Okay, this map shows the key targeted area of induced seismicity research related projects. Most of the locations are related to unconventional hydrocarbon extractions in Western Canadian Sedimentary Basin, New Brunswick, and Quebec. However, Aquistor site in Saskatchewan is related to CO2 or carbon dioxide storage. Next slide, please. Okay, here you can see on the three left panels, you can see the improvement in seismic monitoring system in Western Canada. So from 2016 to 2018, and currently we have nearly 50 seismic stations, broadband and strong motion sensors, streaming real-time data to major data centers from nearly 50 seismic stations. And on the right-hand side, you can see recently deployed seismic stations in Eastern Canada, establishing a reference or baseline regional seismicity pattern in areas where hydraulic fracturing is deemed likely to be developed in near future. Next slide, please. Okay, different studies have been trying to find link between hydraulic fracturing and induced earthquakes in Canada. Unlike US, where wastewater disposal is thought to be responsible for a significant portion of induced seismicity, in Canada the story is different. A spatiotemporal distribution of induced seismicity correlates well with the distribution of hydraulic fracturing injection sites, both in time and in space. Research in Horn River Basin shows that the number of earthquake or seismic events has been increased from nearly 24 events in 2002, the beginning of hydraulic fracturing operations, to about 130 events in 2011, peak period of hydraulic fracturing in this area. And also an independent study in the Northern Mountain Plain in northeastern BC shows that the cumulative number of events catches up quickly with the cumulative number of hydraulic fracturing stages. In other words, it correlates with the cumulative injected volume in this area. Next slide, please. And different studies have been trying to tackle the question of what's the controlling factor on the seismogenic characteristic of induced earthquakes. Can be geological properties involved, or it's due to injection properties. So in the left panel, you can see a result from research started in 2015. You can see the number of earthquake and also seismic moments released by induced earthquake follows the cumulative injected volume in each month, especially if you look at the yellow or red zone in the left panel. And also in an independent study by Kao and his colleague, which has been recently published, showed that the background geological deformation rate or tectonic strain rate plays a key role in induced seismicity. And most of the induced earthquakes are located in 150 kilometer wide north, west, southeast band, where the released moment from induced seismicity is comparable to that of from the background tectonic rate. And under these conditions, the tectonic moments rate, the maximum number of earthquakes have been observed where both tectonic moment rate and injected volume are high. The upper right corner of the figure in the right panel. Next slide, please. So, a detailed understanding of the distribution of the seismicity, both in time and in space, can guarantee or ensure the success of any research effort. So NRCan's induced seismicity research has been also focused on developing or introducing new advanced technique in detecting small to large magnitude earthquakes. So in the left panel, we took advantage of advances in deep learning and also spectral characteristics of seismic waveforms to identify seismic events and discriminate them from noise, and also isolate the major seismic rivals. And the performance is nearly comparable to that from a human analyst, but we could significantly reduce the processing time and improve the efficiency. And on the right-hand side, you can see a novel technique for auto-locating and auto-detecting small magnitude earthquakes. It combines the traditional phase picking algorithm with source scanning algorithm to locate the small magnitude earthquakes due to due to hydraulic fracturing operations. Next slide, please. So the outcome of induced seismicity research has been contributed to improve regulations on the development of unconventional hydrocarbons. Here you can see a full list of these regulations and permits developed, so we can read them, but most significantly it has been contributed to induced seismicity traffic light protocol established in 2015, which carefully monitors the occurrence of any unusual seismic activity in Alberta and BC. Next slide, please. And here's the contact information of Honn Kao, so he would be more than glad to answer your questions.
Thank you very much, Amin.